All right, so remember last Friday we talked about complex numbers. Complex numbers are a mixture of real world numbers like 2 and imaginary numbers like -3i. Together they form one number and we call it a complex number. Last week we added them, and when we add them, remember reals and reals go together, imaginary and imaginary go together, kind of like combining like terms. We did addition and subtraction, and then we did a little bit of experimenting with multiplying just imaginary numbers. And we remembered that when I multiply two i's together, you get I to the power of 2, which will become -1. So now we're going to just take it up just one notch. Now instead of just multiplying two imaginary numbers, we're going to multiply complex numbers. So there will be real parts and imaginary parts. And unlike adding and subtracting, when you multiply, like terms don't matter. Right? Just like when we're solving or multiplying normal variables, a normal number and x can be multiplied together, but they can't be added or subtracted. So same thing with complex numbers. We don't have to follow the only reals can be multiplied or only imaginaries can multiply. You can multiply anything together. There's no rules you have to follow. But adding and subtracting, you do have to follow that like term rule. So we are going to multiply these two using the box method. Now, a lot of you might have done your rainbow method, probably, or did you always do the box? Well, I'm going to do the box method of multiplication, which keeps our page nice and organized, and the reason I am doing the box method is later down the road when we multiply big old polynomials, the box method is going to be the way to go. So, I am multiplying 2 minus 3i, which is our first complex number, by our second complex number, which is 4 plus 6i. So our first complex number, it has two things, and our second complex number has two things. So we are going to draw a 2 by 2 box. A 2 by 2 big old box. Now, it does not matter if you put the first complex number on the top or the side. They can be mixed and matched. The only thing is, I need to make sure that my yellow complex number goes all on one side. It has to either all go on the left or all go on the top. I can't like put part of it on the side and part of it on the top. I've got to keep it together. So I'm going to put my yellow on the left. So I have 2 and minus 3i. So that is just my yellow complex number written up and down. And I'm going to put my blue complex number, 4 plus 6i, 4 and positive 6i, up on the top. And again, this is just my complex number written on the top. You don't need to put the plus. You can if you want though. Each box will be filled in by multiplying the numbers that are in those columns and rows. So if we look at our first top left box, I'm multiplying 2 and 4. 2 times 4 is 8. Remember, we're multiplying, so everything in our box gets filled out by multiplying. A lot of students accidentally will add or accidentally will subtract. We're multiplying, so we want to multiply. This next box would be 2 times 6i. 12i. Just like a variable. 12i. Our bottom left box will be -3i times 4. -12i. Don't forget the i's. And last but not least is the tricky box. We have -3i times 6i. Negative, watch, I'm going to write small and you'll see right. Why? Negative 18
I to the second power.
I to the second power. But we're not done because what does I to the second power become? So this is really negative 18 times negative 1. Negative 18 times negative 1, which is positive 18. Okay, so that last box is a little tricky because we're multiplying two imaginary numbers, giving us I squared, which we turn into a negative 1. Now all I have left to do is combine my real numbers, combine my imaginary numbers together, and I get my final answer. So inside my box, which numbers are real numbers? 8 and 18. These can be combined, so let's add them together. 8 and 18 is 26. Which numbers are imaginary?
12i and negative 2.
Which, what do those add up to?
Negative 144.
Remember, adding.
Oh, adding.
That's 0. So our final answer is just 26. 12i and negative 12i is 0. So we multiply to fill in our box, and then we add our like terms together. And by like terms, I mean we add our reals, add our imaginaries, and that will be our final answer. Okay, let's do another. Draw your box. 2 by 2. For the sake of showing you that it doesn't matter, this time, like I said before, it does not matter which side you put them on. Instead of putting it on the left this time, I'm going to put it on the top. So negative 1 and negative I. What number is in front of this? This I. If you like to put your 1, you can put your negative 1i. On the left side, I'll put my other complex number 6, and my second term, negative 5i. Again, as long as you keep the correct complex numbers together, it doesn't matter if you put on the top first or the side first, you get the same answer. Because the order of multiplication does not matter in mathematics. Okay, and now to fill out our box, we will multiply. Filling in our box, we multiply, and then we add our like terms to simplify at the end. So top left box, what do we got? Negative 6. 6 times negative 1. In my top right box, I have 6 times negative 1i. Negative 6i. In my bottom left box, I have negative 5i times negative 1. 5i. And the tricky box, where I'm going to write small so I can simplify, negative 5i times negative 1i. 5i squared, and our I squared becomes negative 1. So 5 times negative 1, negative 5. To write our very final answer, we just combined our real numbers. For real numbers, we got what? Negative 6 and negative 5. For imaginaries, we got 5i and negative 6i. So we just add them together. Negative 6 and negative 5 gives us negative 11. 5i and negative 6i gives us negative 1i, or just negative I. And that is it. That is how you multiply two complex numbers. All done.